Again, this is exam 1 review for EGR 211. Exam 1 review. And there's going to be a closed book part on the exam, and there's going to be an open book part. And you have the review sheet. So there's 4 different problems given for the closed book part. The problems on the closed book part in the exam are going to be very, very, very similar to these. But it could be all 4 of these types of problems, or maybe 3 out of the 4, but nothing more than what you see here. So let me go over some of these problems. Let me start with the first one. Let me do the example problem 1. Let me do 1A. And problem 1A says that there's a force that passes from this point through this point, and the magnitude is 100 pounds. It wants to know the unit vector that passes through the 2 points and to find the Cartesian vector F. So let's go do that. So to find the vector that passes through the 2 points, it'll just be that second point, 8 minus 2, 7, minus the first point. So mainly just subtract those coordinates. So be 8 minus 2, then minus 2, minus 3, then 7 minus 8. So it's 8 minus 2, 7. And then minus 2, minus 3, minus 8. So take the second point minus the first, and that's going to give you 10i minus 5j minus 1k. Now we need a unit vector in this direction. Now, but before we can find the unit vector, we have to find the magnitude of v. And that's just the components squared. And when you put that on your calculator, around 11.22, I rounded it off a little bit. Now to find the unit vector in the direction of v, you take v divided by its magnitude. Get that. And I'm going to put that in my calculator and get the actual numbers. Get that for the unit vector that passes through those 2 points. And so that's the answer to the first part of the problem. Then the second part asks us for the force vector. And to remember, the force vector is just going to be the magnitude times the unit vector that passes through the points. And we know that the magnitude is given as 100 pounds. and just multiply that times the unit vector. I'm sorry, this should be a J right here. That's a J minus 9K. And that's your answer. So those are the two answers for the first part of the problem and the second part of the problem. So again, be sure you can do problems like this without any notes, without your book. The main thing you just have to remember is for the vector itself, take the difference between the 2 points given to get the vector in that direction. Find its magnitude, which is just a square root of the sum of the squares. To find the unit vector, take v divided by its magnitude. That'll give you the unit vector. And then the force vector is just simply the magnitude of the force times the unit vector gives you that. And all of those problems, you can see the four number in the number one there, they're all the same type. So if you want to practice more of those, they're all the same. So you'll have one problem like this on the exam. So be sure you understand how to do that. And of course, whenever you do these problems, be sure to show all your work. In other words, show all these steps. And again, on the practice, I said to show the steps on the same sheet, or excuse me, on a separate sheet. But on the exam, you'll have room on the exam to show your work. Be sure to show all these steps when you do the problem. And the next problem that we'll want to look at is problem 2, and that's really an easy one. In fact, that might be so easy it might not even be on there. If we leave any out, it'll probably be number 2. But let's take a look at that just to be sure. Again, that could be on the closed book part. Once again, I'll do 2A. It just says you have to find the magnitude of the force, and that's very simple. Problem 2, once again, I'll do part A, and the magnitude of the force is simply the square root of the sum of the squares. And if we put that into the calculator, 177 squared plus 318 squared, we get 568.7. I didn't say what that was, did I? I guess we just said, I didn't put any units, so I guess we can't put units here, but it's probably going to be newtons, but just leave that off. So again, problem 2 is very easy. If any of the problems are left off of the closed book part, be problem 2, because that's just so easy. But be sure you're able to do it though anyway, just in case. The next one we want to look at is problem 3. Again, you have some examples there of problem 3. And again, there'll be a problem very, very similar to one of these on the exam. So let's take a look at this. Let's maybe they're all pretty much same. Let me look at this 3B, problem 3B. And so we have to find the force vectors. And so let's start with F1. And you can see the X component is going to be going in this direction. And the Y component of this force one is going to be going in this direction. And of course, remember, if you want to find the X component, it's going to be 375, which is the magnitude, times the X component on this. Again, this is the X component here. So use the X component here, which is 4/5. So it's going to be 375 times 4/5. And notice that's going to be going in the negative direction. I. And then for the Y coordinate, going to go in this direction here. Plus 375. And then use the Y coordinate here. 3/5 J. Again, so because we're looking for the Y component or the J component, it's going to be the magnitude times the Y component here on the little triangle divided by the hypotenuse, this. Again, let's just check our directions. Negative for the X, positive for the Y, which we have here. And so this is going to be 375 times 4 divided by 5. Minus 300I. 375 times 3 divided by 5. Plus 225J. That's the first answer. Then the second answer. Again, let's look at F2. Here's F2 again. Notice the 30 degrees is here, and then the adjacent side to that one is going to be the X direction. So that's going to be F2 is equal to the magnitude, which is 100 cosine 30 degrees. And then if the X was cosine, the other one has to be sine. Plus 100 sine 30 degrees, J. And so it's going to be 100 cos 30, which is about 86.6. 100 sine, which is 50. And that's our answer for F2. Let's just check the signs again. It's positive in the X direction, positive in the Y direction. So those are going to be positive. Then finally, for the last one, F3, you can see it's going straight along the x-axis. Straight along the x-axis. So that means that all the force is going to be in the x direction. So it's going to, and it's positive x direction. So it's going to be 100 I. And these were all given in newtons, by the way. So Newton, Newton, Newton. So those would be the first three answers that you'd have in the answer box there. Again, be sure to show all the steps though here. Show what you did here, here. And then finally, the resultant is just the sum of all those. So sum of the x components, which is minus 300 plus 86.6 plus 100. Like this. Then sum of the y components. And that's the result. Just add up all the x components. Minus 386.6 and 100 gives us this. Add up all the y components. 225 and 50 gives us 275. And that's your answer. Again, be sure when you do, if you do this on the exam, be sure to show, you know, the cosine, the sine somewhere. You could either show it here, or if you want to show it like on the picture, you know, how you did it on the picture, but be sure you show that somewhere. And then these are your answers. And once again, be sure that you remember these rules, you know, that if you're doing the x component here, use x component in the little triangle. If you're doing the y component, do the y component in the little triangle. So be sure to remember that, because you can't use your notes for the closed book part. And same with the sine and cosine, whatever the closest side is. In this case, the closest side to the 30 degrees, the adjacent side was x, so x is going to be cosine. So just remember all that and show your work. Again, just practice those. There'll be one very, very, very similar to that on the exam. Finally, I want to take a look at problem number 4. Problem number 4. And if you have the version of this that has these things on it, you can take those off. Probably on the exam, I'm not going to have it like that. I'm just going to ask you for the total moment. I think I've sent out revisions of this, so all that's going to be on the exam, it'll just ask you for this part here. It's going to ask you like for the total moment of all these forces here. So it wants the total moment of all these forces. And so once again, let me look at problem 4A. And once again, let me look at A. And so we want to find the moment. And so let's go through each force. So let's look at force 1. So for force 1, you can see that it's going that direction. And so you remember, you're allowed to extend these out this way. And then the distance from force 1 to A is going to be 4 feet. So the moment caused by this here is going to be 4 feet times that 300 pounds. And now for force 2, we have 250 pounds this direction. And then we want to break this up into X and Y components. And of course, there's that little box there, a 4, 3, 5. So again, 4, 3, 5. And so the force in this direction is going to be 250. Again, we want the X component. So use the X component here, 450 divided by 4/5. Excuse me, 250 times 4/5. That's going to be 200. And then this component here is going to be 250. And once again, you want the Y component times 3/5 here. That's going to be 150. And now we have to figure out what the distance is from A. Again, A is, say, down over here. The distance A to each of these forces. So the distance A to this one, according to our picture here, is 2.5 feet. And the distance from A to this one here is going to be 4 feet. So we have that for force 2. Finally, for force 3, it's kind of like out over here. And this is force 3 was equal to 200 pounds. We have an X component and a Y component. And notice in our picture, the 45 degrees is right here. So that's going to make this to be 200 cos 45 degrees. This is going to be 200 sine 45 degrees. This could be 141.4 pounds. £141.4. And once again, this is point, say point A is over here. And see what the distance is in this direction. It looks like it's going to be 3 feet. And in this direction, from A, it looks like it's going to be 6 feet. So now we want to find the moment, the total moment of all these. So let's go through each one. So for this one here, so the moment of this one about A, you can see this first F1 is turning at counterclockwise. So we'll call that positive. So this would be 300 times 4 feet. My pencil keeps breaking. 300 times 4 feet. Then go to F2, and let's take this one here. Say this 200-pound has a moment arm of 4 feet. And then this 150 has a moment arm of 2.5 feet. And so just remind, this one here was from F1. These two here were from F2. And then finally, we want to do F3 over here. Now, notice once again, these were all so far counterclockwise. So this was counterclockwise, counterclockwise, counterclockwise. And then finally for F3, now it looks like this one here is turning it clockwise, this 141, and it's at 6 feet. So since that one was clockwise, going to make that negative. And then this component here was 141 also. That's also going to be clockwise, but this is at 3 feet. And that was for F3. So then our total moment is going to be just this all multiplied out, 300 times 4 plus 200 times 4 plus 150 times 2.5 minus 141.6 times 6 minus 141. Excuse me, this was 141 let me go back, sorry. 141.4 times 6, 141.4 times 3. And this gives you 1102 pound-feet or foot-pounds. And since it's positive, that must be counterclockwise. And that's your answer. So when you get a problem like this on the exam, mainly break down each force into its X and Y components. Then see what the moment arm to each component is. And then just put them all in here add them up, and that's your answer. Like I said, this is the final answer. But once again, be sure to show all your work. On here, I say show it on a separate page. I'll give you room on the exam to show it, right on the exam. So show all these steps. So be sure you know how to do those kind of problems. There'll definitely be a problem like that on there. And you can see there's several examples on the practice problems. So again, that's the closed book part. Again, remember, you can't use notes. So any techniques we use here, be sure that you know how to do them from memory. And yeah, so be sure you can do them from memory and show all your work. So you've seen now all the types of problems that'll be on the closed book portion. They'll be very, very similar to these.